Hello, in this video, we'll see how to use Tensorflow tools, the data and the gradient tape to implement an autoencoder. So let's go to the file. So the purpose of it is to demonstrate how a realistic autoencoder can be implemented using the gradient tape and custom layers. So let's first import the libraries. So now just set some parameters. Probably worth running is in the autoencoder we'll have the latent dimension 128, some middle layer 256, and of course the incoming data will be using MNIST, so 784. And then load the MNIST data. This is the standard using the old usual load data, and then scale it, and then test and train data, reshape it to 784 instead of 28 by 28 image panel. Then here's the new thing that the TensorFlow 2 provides, a data set. So here's the from tensor to slices of X-train, and I'll just have a training data set. This time we'll have a batch size of 256. Okay, so it will create the slices of this. So how do you create a custom layer? It is similar to PyTorch that we have done a while ago. We'll use a class of, let's say, encoder, and we'll inherit most of the features from the TensorFlow layers layer. First, you have to the constructor. So here's a layer 1 and layer 2. These are all dense layers with certain numbers, hidden dimension, which was what 256. And latent dimension, which is 128. And then actually the forward loop path is here in the call function. So inside the encoder class, we have a call, and the encoder layer 1, I'll call that, that transform from the input features down to the hidden. And then the second one, the layer 2, gets that and then transmits into a latent and return it. So that's our encoder. The decoder is very similar. So we'll have layer 1 and layer 2, which is the hidden and original. Okay. And here the decoder layer 1 takes the encoded, and that's what we get in from the encoder, and then goes here to the hidden layer, and then that one gets passed on to the next layer, which spits out an original dimension. So that's what we return. And then there's the whole autoencoder class that combines the two. So here we have a loss and encoder and decoder. Okay. So the encoder and decoders are here, hidden and latent dimension, all this given. So the encoder gets input feature and gets the encoded data. The encoded data goes to decoder and have reconstructed, and that's what the autoencoder will give us. Okay, let's build the autoencoder. So I'll call this autoencoder class with all necessary parameters, okay, which we have 1, 2, 3. It's given here. And then the optimizer will use Adam optimizer. And here's a custom training loss. Well, it's the average, the mean of the square of this prediction and the real of the pixels, data points. And then we have a custom training where I use the gradient tape, isn't it? So inside the with TF gradient tape as tape, we'll have the prediction comes from the model of getting the original data. And then using the predictions and the original, we have a reconstruction error. That reconstruction error, we want to get the gradient and then compute in a way to change the weights to minimize the errors, isn't it? Using the gradients, that's what we do. Okay, let's, the training the network is that we'll use that training for each epoch. So the train gives out actually the error, so we can check the historical errors, so get the error values. But also in the meantime, all the, for each epoch, the neural weights gets updated to using the derivatives that using the gradient tape. Okay. So this is the training loop. And then here we'll have the training done. So this is going to take a while. So let's come back when it's done training the network. Okay, it's done training the network, the autoencoder. So let's plot the training losses, which are shown here. So you can see that it's smoothly decreased. And then constructing the image, I basically plot the X-test, the original data, and then the reconstructed X-test. I'll just take 10 of them and redrawing. And yeah, sort of it does a reasonable job of recreating. So this shows how to implement autoencoder in Tensorflow 2 using the custom layers and the gradient tape to evaluate the gradients. Thank you for watching this video.